Metro Ninjas, and welcome to another exciting day of geometry. So in our past few lessons, we've been talking about quadrilaterals. So we're going to continue talking quadrilaterals today, finding area and perimeter of rhombi and trapezoids. Okay, so the first shape we're going to come across is a rhombus. If we think back to last unit, the properties of a rhombus are still going to be present. The fact that a rhombus has 4 congruent sides. The diagonals intersect at a right angle. So 4 congruent sides, we can show that with our congruent tick marks. Diagonals form perpendicular lines. Those are still all there. And like you've seen in the past couple lessons, that's how we are going to find a lot of missing side and or diagonal links. Remember, a rhombus does not have congruent diagonals. A rhombus does have diagonals that bisect each other, but they are going to be different lengths. So we might have to find one diagonal, both diagonals, a side, or maybe a little bit of all of it. So first and foremost, our area formula for a rhombus. Area equals diagonal 1 times diagonal 2 divided by 2. So we're going to find the full length of each diagonal. Does not matter who you call 1, who you call 2, but they are going to be different lengths because this is not a rectangle nor a square, so they are going to be different lengths. And then perimeter, we can solve it just like a square because in a rhombus, all of our sides are congruent. So we can just go 4 times our side length. Any questions before we get rolling? All right, so looking at number 1, okay, the figures below are rhombi. It's important that they tell us that, or else we'd have to prove it, and that's a whole different animal. Okay, so the figures below are rhombi. Find the missing values. It wants us to find the area and perimeter of this rhombus. So right now, we have all the information we need to be able to find the perimeter. For perimeter, it is simply 4 times our side length. In this problem, our side length is 5. So 4 times 5, the perimeter, or excuse me, 4 times 5, yep, our perimeter is 20. And then since they didn't give us a units, we can always just drop a units in there. Okay, perimeter, nice and easy, nothing too crazy. Area, we need diagonal 1 and diagonal 2. We have one of our diagonals. At least we have half of a bisected piece. Since this half of the diagonal is 3, and rhombi are parallelograms, the other half of that diagonal has to be 3. So we know diagonal 1 is all the way across 6. Problem is, we do not know diagonal 2. This is where we use our old friend, the old reliable Pythagorean theorem. So that's a great question. We said, how do we get 6? Since this half is 3 and it's a parallelogram, the other half also has to be 3. So the full length across that diagonal is 6. 3 plus 3 is 6. So it's 5 because they're all 5. Good. All right. So what we need to do is we need to find, bless you, this piece of our diagonal. If we have a right triangle and we know 2 of the 3 sides, Pythagorean theorem is going to be our friend. Identifying A and B does not matter. It does matter that we correctly identify C, but if we remember, C is always across from our 90. In this case, 5 is our hypotenuse. So x squared plus 3 squared is 5 squared. Okay, now be careful, we can't find this whole length because that would not be a right triangle. Rhombi do not have 90-degree vertices, or else we'd call them a more specific name for a four-sided figure that has all four congruent sides and 90-degree vertices. Square. Or else we'd call them a square. So we get x squared plus 3 squared is 5 squared. X squared plus 9 is 25. Subtract 9 from both sides. X squared is 16. And then how do we get rid of a square? With a square root. So our length of that half of our diagonal is 4. So we know that's 4. If that half of our bisected side is 4, the other half has to be 4. Yes, ma'am. Okay, so we've got a 4 and a 4, which tells us the full length is 8. So diagonal 2 is 8. All the way across that diagonal from vertex to vertex. Area is diagonal 1 times diagonal 2 over 2. So we get 6 times 8 over 2. Six times 8 is 48. And then 48 divided by 2 is 24. And then again, they don't give us a unit. If we need to, we just drop a unit squared. Any questions on number 1? Moving over to number 2. They told us we've got a rhombus that has diagonals of 18. So we'll let this guy be 18 and diagonals of 80. So we'll let the other diagonal be 80. So on this one, right out the gate, we can solve for area. Because all we need for area is diagonal 1 times diagonal 2 over 2. Do we have diagonal 1? Check. Do we have diagonal 2? Absolutely. Which means we have everything we need to be able to find our area. So diagonal 1 is 18 times 80. I'm going to go ahead and use parentheses because that's where we've been doing it. 18 times 80 over 2. $18 times 80 is 1,440. And then 1,440 divided by 2 leaves us with 720 inches squared. That's awesome. That's exciting. That would be the area, correct. We do not have enough information right now to find the perimeter, though, because perimeter is 4 times our side length. Unfortunately, we do not know our side length, but we have the ability to find it. This blue diagonal and our green diagonal, what do we know about them because they're a parallelogram? They are being bisected. Excellent. Okay, so if the full length of our blue is 80, each half length has to be 40. Do we agree there? Same thing with our green side. If the full length of our green is 18, each half has to be 9. There is again our rhombus. So we know this is a right angle, which makes this whole thing a right triangle. If we know 2 of 3 sides on a right triangle, we are going to use the Pythagorean theorem. And this time, x is our hypotenuse. That's our C. So 9 squared plus 40 squared is our side length squared, our x squared. Nine squared is 81. 40 squared is 1600. '81 plus 1600 is 1681. We get rid of a square with a square root. And then the square root of 1681 is 41. So now we know each one of our sides is 41. We know that because this is a rhombus. And in a rhombus, sides are congruent. Perimeter is 4 times our side length. And in this problem, our side length is 41. 4 times 41, 164 inches. Any questions on number 2? All the outer sides are the same because it's a rhombus, correct? All right, number 3 brings an old friend back. Anybody recognize that old friend? It's not a kite. They told us these were all rhombi. It is a 30, 60, 90 triangle. Everybody's favorite type of triangles. The good thing about this 30, 60, 90 is we have an even hypotenuse, which is going to make our life a little bit easier. So since this is a 30, 60, 90, and we're not going to use the trick that some people like to show off, we're going to use our ratio to find our missing side length. The ratio for every 30, 60, 90 on the planet is what? 1 √3, 2. And for those of you watching at home, that is our short leg, our long leg, and our hypotenuse. So every single 30, 60, 90 triangle on the planet follows the ratio of 1 √3, 2. This particular 30, 60, 90 is a short leg of x because it's opposite the 30, long leg of y opposite the 60, and then a hypotenuse of 12 because it's opposite our 90 degree. So we're going to set up 2 proportions using these ratios. We're going to use the thing we know twice. We know hypotenuse. So we got 1 over x equals 2 over 12. And √3 over y is 2 over 12. We could find the short leg and then apply that to our long leg if we wanted. But then we're just opening ourselves up for a mistake. If we use the constants that are given to us, we're less likely to make a mistake. I'm going to solve both of them because I need x and I need y. No, if you solve X and then try to use that to find Y, it opens you up to get a mistake. But if we always use the one we have, whether it's a short leg relationship, long leg relationship, hypotenuse relationship, less likely to make that error. So we get 2y is equal to 12 root 3. Divide both sides by 2. Outside numbers divide by outside numbers. So we don't have anything to divide that root 3 by. So all we have is 12 divided by 2, which is 6. And then we do the same thing to find x. You can reduce that fraction on the right side if you want, but you do not have to. 2x is 12. X is, whoops, not divided by x. I was trying to say x and write 2. X is 6. So now we have 6 and 6. We have 6 root 3 and 6 root 3. So what is the length of diagonal 1? Let's say the vertical diagonal. 12. The full length across is 12. And I'll highlight it for us. So this full length across is 12. Yeah, essentially, if you multiply together and divide by 2, you're just like multiplying by half. Be careful there, because in this case, I don't see an issue with it, but we'd have to look at the other ones. So if we go back here, 3 times 4 is 12. See how it didn't work? Is that what you said? Half the diagonal? If we only did half of one, it wouldn't work. I think you could do half of one diagonal times the full of the other one. So I could have just done 4 times 6. Because by what you were saying, you'd be multiplying by 1/4 instead of 1/2. Because you're doing half twice. So that won't work. Right? And then the length of our other diagonal is a little trickier. It's a little trickier because they hit us with these roots. Remember, our radicals act a lot like variables. How many root 3s are present? There's 6 root 3s on the left, 6 root 3s on the right, for a total of how many root 3s? 12. So diagonal 2 is 12 root 3. Area formula is diagonal 1 times diagonal 2 over 2. So we get 12 times 12 root 3 divided by 2. (144) root 3 over 2 reduces to 72 root 3. Magic. Let me slide that over so we can write that a little bigger. (72 square root 3 meters squared). And then the nice part is perimeter is given to us. Perimeter is simply 4 times our side length. The given side length is 12. So 4 times 12. 48. 48 meters. All right. Let's look at number 4. The perimeter of rhombus is 52 meters. So we just did perimeter on the last one. So what does perimeter mean to us? Perimeter is 4 times the side length. So in this case, we don't know what the side length is, but they kind of told us what it was, didn't they? Absolutely, we're going to divide by 4. So we're going 52 meters equals 4s, and then divide by 4. So our side length is 13 meters. Perfect. Which means if one side length is that, all of them are that. But then there's our old friend, the sneaky snake himself. We're missing a diagonal piece. In that right triangle, if we know 2 out of 3, we can always use our Pythagorean theorem. Another clue that we need to go Pythagorean theorem is, do we see a 30, 60, or 45? No. So our special right triangles are not in play here. If you see a 30, 60, or 45, that's when you kind of know your special triangles are coming at you. Right, so x squared, excuse me, plus 5 squared is 13 squared. 13 is our hypotenuse because across from the 90. X squared plus 25 is 169. Subtract 25 from both sides. X squared is 144. Last but not least, go ahead and square root that bad boy. So now we know the other diagonal is 12. So we've got 12 and 12, 5 and 5, because it's a parallelogram, and parallelograms bisect opposite angles. Area of a diagonal. Our area of a rhombus, diagonal 1 times diagonal 2 over 2. Full length of a diagonal is, doesn't matter which one you start with, 24. Our other diagonal is 10. Twenty-four times 10 is 240. 240 cut in half is 120. 120 meters squared. Yes, absolutely. All right, let's go straight down. Okay, a rhombus has an area of 40 centimeters squared. If the length of a single diagonal is 10, find the length of our other one. Area of a rhombus is diagonal 1 times diagonal 2 over 2. What information have they given us in this problem? They gave us the area. The area is 40, and they gave us one diagonal. Again, it does not matter which diagonal we choose. We know one of them. Okay, so I'm going to go diagonal 1 times 10. Does not matter which one we go with. Yes. Because it told us in the equation area, rhombus. So those were our keywords that told us, hey, we're using that formula. Does that help? What other formula would you think to use there? A perimeter? Right? So the only two things we know about rhombus is area and perimeter. So that's the only two formulas we got. Okay. We need to clear that denominator on the right side so we can either cross multiply, or what you guys like to do is multiply both sides by 2. You're doing the same thing. Multiplying both sides by 2 cancels out that 2 on the right, leaving me with 80D, or 8. 80 equals 10 times diagonal 1. And our last step is divide by 10. So diagonal 1 is 8. That brings us to our friend, the trapezoid. What's the difference between a trapezoid and a rhombus? All 4 sides are congruent. Is a trapezoid a parallelogram? No. Okay. So our trapezoid formula, area is base 1 plus base 2 over 2 times the height. Base 1 plus base 2 over 2 should look familiar from our last unit. Base 1 plus base 2 over 2 was simply the median. It was our mid-segment formula. You guys will be given the formulas on your assessment, so there's no need to panic. But hopefully you recognize that. Okay, and then height is the same. Height is the distance from base to base. Okay, so looking at our diagram over there, we have a height that connects base 1 to base 2. Heights are perpendicular to their bases. And then it does not have to be an isosceles trapezoid. It could be, but it does not have to be. And then just like our parallelograms, our rectangles, anything really, to find the perimeter, we're just going to add up all the sides. We good? Let's do some math problems. Yeah. All right, 12 is base 1. 18 is base 2. And then 4 is our height. Did it matter if I put 12 or 18 as base 1 or base 2? It does not, because they're being held together with addition. Addition doesn't change signs. Area of a trapezoid is base 1 plus base 2 over 2 times our height. So 12 plus 18. Times 4. Order of operation tells us that this has to happen before our multiplication. PEMDAS, parentheses, exponents, multiplication. What's happening in that parenthesis needs to happen before I try to multiply by 4. So 12 plus 18 is 30. 30 divided by 2 is 15. 15 times 4, 60. Oh, rats. We don't have perimeter. How come? Yeah, we don't know our legs. We're like Lieutenant Dan. We don't have no legs. Oh, it doesn't want perimeter on this one? We could find the legs. Oh, is the other one got it? Oh, the one below it does. Well, that's just goofy. All right then, Peter. Number 9. Number 9 is a little funky. Height is simply what? Distance from base to base. In this trapezoid, my heights or my bases are these lines. I know that because height is perpendicular to both. Okay, and then also I've got a slanted side, and then in trapezoids, my bases need to be parallel. Good. Okay. I was just showing you that those are the legs. We're going to take them off. I don't have a height, but can I find a height? Absolutely. How come? I know that I've got what kind of triangle? I've got a right triangle, which means I've got a special right triangle that is 45, 45, 90. One of your classmates asked yesterday, if we've got 45, 45, 90, can't we just rock the Pythagorean theorem? Absolutely. But you guys are rock stars. You are capable of using our ratio. So 1 root 2 is the ratio for our 45, 45, 90. Okay. So I've got x and then 8 root 2. 1 over x is root 2 over 8 root 2. When we divide a number by ourselves, it becomes 1. So for this problem, x is 8. That means our height is 8. That also means this piece of the rectangle is 8. That's important that we acknowledge that that piece of the rectangle is 8. Why? What does that do for us? Yeah, it lets this piece of our top be 7. I got that by doing 15 minus 8. Since it's a rectangle, if that blue section is 7, the bottom blue section is 7. Since it's a rectangle, since this piece is 8, that side also has to be 8. So now we have all of our sides that we need. Are you ready? Area is the median times the height. Base 1 plus base 2 over 2. Times height. So 15 plus 7. I need 8 because that's the height. That's the distance from base 1 to base 2. And I also need 8 because that is the perimeter. 8 also unlocked 7, so 8 was pretty critical for this problem. $15 plus 7 is 22. 22 over 2 is 11. And then 11 times 8 gets us an area of 88 units squared. And then perimeter, we're just going to add up the outsides. So perimeter is 15 plus 8 plus 7 plus 8 root 2. So I went 15 to 8 to 7 to 8 root 2. Combine like terms. These are all like terms. 15 and 8 is 23. 23 plus 7 is 30. That is as far as we can go. We cannot put 30 with root 2 because they are not like terms. All right, you want to do one more? Do you want to do 8? Sure. Number 8 might be the easiest one on the board. Number 8 is trying to mess with you. How are they trying to mess with you? They didn't give us base 1. They didn't give us base 2. We don't have a right triangle that'll help us solve those. Those sneaky snakes. They did give us, though, the length of our mid-segment, of our median. The median is 12. Okay? So remember, median is just base 1 plus base 2 over 2. That's what a median is. So if you look at our area formula, base 1 plus base 2 over 2 times height, they already gave us that math. Okay? They already told us base 1 plus base 2 over 2. They did our math for us. They're helpful. Okay, so 12 times 6. Told you, easiest one on the paper. 12 times 6 is, right part, 76. 72.
Oh.
76 did not feel right. Oh, it happens. Transcript error. I do want to do one of the ones at the bottom, though. Number 11 is good because it makes us label our own side. We got plenty of time to knock this out. So it tells me that an isosceles trapezoid has legs that measure 10. So each one of these legs is 10 centimeters. It has a base of 12 and a base of 22. And then our base angle is 60. What part of our graph or what part of our figure is not drawn that has been drawn? Our what? Our height. Our height was not given to us. But guess what we can find? Our height, because what type of figure is chilling down here? A right triangle, but specifically a 30, 60, 90. Now remember, the shortcut, if you have the short leg, makes your life easy. But they didn't give us the short leg, did they? They gave us a long leg and a hypotenuse. That's why the ratio is our friend. The ratio will not steer us wrong. I'm going to go ahead and see if I got room over here. So we get √3 to 2. And then x to 10. How come I did not include the 1? Why didn't I put the 1 √3 2 all the way out? I'm not looking for the short leg. Short leg doesn't have any bearing on this problem. So √3 over x equals 2 over 10. Just for the sake of simplicity, I'm going to go ahead and reduce this from the beginning to be 1/5. Now when we cross multiply, it takes us directly to our answer of 5√3. Right. Now we have our area. Area is the mid-segment, base 1 plus base 2 over 2 times our height. Well, plus 22 over 2 times 5 square root 3. Twelve plus 22 is 34. 34 sounds right. Remember, go ahead and solve all of that parenthesis before you try to multiply across. Then we get 17, because half of 34 is 17, times 5√3, leaving us an answer of 80√3 centimeters squared. Not right? 80 what? 85? Thank you. All right, that concludes our lesson on the area of rhombi and trapezoids. Y'all have a great day.